All right, so here I am on the criteria within page, and you can see the slider are already set with a default balance within 40% on ethics, 40% on technical score, 20% on probability. That's the IBIS-X baseline, a sensible trade-off that works for most users out of the box. But in my case, I am a PhD student working on how socio-economic factor affects academic success. So I really need strong technical quality in my data. I mean, clean, well-structured, reliable, and I still want to say ethically compliance, and I like a bit of community validation on the top. So let me tune this slider to fit my actual research priorities. First, I push technical score up to 60%. That's my top priority. Then I bring ethics down to 20 or 30, just enough to stay on the safe side and avoid any GDPR red flag. And I trim priority down to 10%. I'm not chasing trends, but a little bit of community signals doesn't hurt. And right there at the bottom, you can see the active criteria updating live. Ethical score 30, technical score 60, and probability score 10. No black box here. I can see exactly what the system is going to use to rank my dataset. And here comes the interesting part. IBIS-X generates this Apache e-charts its maps. 3 candidates datasets laid out across my 3 criteria. The color code is really straightforward. Red is low, orange is medium, green is good, and blue is excellent. First column, edX. Yes. All 3 datasets, it's 90%, solid blue, excellent. My ethical constraint is satisfied across the board, so compliance is not an issue. Second column, this is where things start to differ. Automated essay scoring sits at 63.1. Open University learning analytics at 65, and the assessment tutoring datasets leads to PAC at 69%. All these are in the green zone, but assessment is clearly ahead. Let's see the third column, probability. Automated essay drops to 59%, still green, but closer to the medium zone. Open University and assessment, on the other hand, both sit at 88%, excellent, in blue. So the community really trusts this too. And cross-reading the 3 columns, assessments win on technical quality, ties ethics, and ties probability. It's a clear overall winner for my thing. And that's it. In under a minute, with zero data science background, I started from a balanced default, tuned 3 slider to match my actual research needs, and landed a clear winner across the criteria. That's exactly the point of multi-objective weighting in IBIS-X. My preference drives the ranking, and the heat map turns a complex multi-criteria comparison into an instant virtual decision. Alright, so here I am on the IBIS-X dataset catalog. I am an intermediate researcher, level 3, and I want to predict a classification model on the classic IRIS dataset. Let me search for it right there, IRIS. And there we go, classic features IRIS dataset 150 instance. Biology domain, ethical score of 67%. That's exactly what I'm looking for. I hit select and IBIS-X drops me straight into the ML pipeline. Okay, first step, dataset overview. IBIS-X give me a quick recap: 115 rows, 6 columns, quality score 83 out of 100. Nice. I've got a clear reference data set to work with, and I confirm and move. And to the step 2. Okay, that's good. Step 2, object type. I need to pick my target variables. But since I want to predict iris species, the obvious pick is the species column. But for the task type, classification or regression, instead of guessing, let me call the AI guide. That's one of the nice touches of IBIS-X. The AI agent assistant is analyzing my dataset and my column target, and here is the verdict. Okay, that's good. The AI recommends classification because species is categorical with 3 distinct labels. And the reasoning is clear, and I agree with it. So yeah, that's good. That's good. I will apply the recommendation and move on. Step 3, data cleaning. IBIS-X offers a smart multi-column analysis, so let me launch it. And the result is pretty straightforward. Oh, quality score 100 out of 100, 0 missing value, 0 column to clear. And by the way, IRIS is a textbook dataset, so no cleaning needed. I will skip the details here and move on. And the step 5, the final preparation. IBIS-X converts everything to numerical formats, but just before we should select a data split. The default is an 80-20 split, 80% of training, 20% for to test the model on data it's never has seen, and that's a standard for dataset this type, this size. So I will keep it and move on. So as I said just before, the IBIS-X converts everything to numeric format and scales the variables. We have standard scalar for normalization and one hot, encoding for categorical variables, and both recommended by default. I won't dive into the details here. This is not the part that matters most for the demonstration. I just validate and move on. Step 6, here we have, here I've got decision tree and random forest. This time I'm not using or calling the AI guide because I already know what I want. And it's random forest, excellent accuracy, robust, ready for multi-classes classification. So it's perfect. It's a perfect fit for our dataset IRIS. Step 7, hyperparameters. IBIS-X proposes 3 presets: balanced, high accuracy, and fast. I go with balanced, a good trade-off between speed and accuracy, and that's locks in 100 trees, and max depth 10. And bootstrap enabled, so yeah, it's exactly what I need for a clean baseline. Okay, IBIS-X give me a full recap before firing things off. Here is dataset, random forest, etc., etc. So everything's checked out. I confirm the credit consumption, and I launch the training. And here we go. IBIS-X walks me through the process in real time: loading, pre-processing, training, evaluation, and the log updates live. So I always know exactly where the system is. And training completed. So my model is ready. Generate general results. Whoa, 97% overall performance, excellent. F1 macro at 96.7, OOB score at 95.8, F1 score 86 96.7. Yeah, that's pretty good. All the metrics in the excellent zone, strong, stable model. But honestly, that's not the interesting part. What I really care about is why the model is performing this well. So let me jump to the explainability tabs. And here is where it gets really interesting. Global shape explanation across the entire dataset. The ranking is crystal clear. Petal length, petal width, those two features alone drive almost all of the decision making. The sepal length contribute a little, and this one is I guess is sepal width. It's barely anything, so don't worry about that. Yes, and there is the sorry. IBIS-X also tell me what's my cognitive level. So here it's intermediate, and triggers me 3 guided questions tailored to that level. So let me generate the personalized explanation. So we just have to click to this button, and the time is over 1 minute, less 1 minute now. Yeah, that's pretty fast. Okay, and here is the output. Tagged intermediate, shape method, and generated in 0.1 second. Now look at how IBIS-X talks to me at this level. It mentions 97% accuracy, F1 macro of 96.7, OB score at 99.2. We have two explanation about shape. It then breaks down the shape importance, petal width, and petal length. It refers the coefficient matrix, 50 over 50 on Setoya. That's pretty good. And 48 over 38 for versicolor. And Virginica with a 90% recall on Virginica, and it even gives me the critical threshold on petal length at 4.5 centimeters. That's amazing. I think that's exactly what intermediate means in IBIS-X. A real ML vocabulary, shape values, OB coefficient matrix, but every terms come with context. For example, a novice will get a narrative with everyday logic. Like a team of 4 team experts, for example, and an expert will get a dense technical synthesis with bias variance trade-offs. Me at the level 3, I get the analogical middle ground, so it's okay. I think it's perfect for me. And that's the full IBIS-X pipeline, end-to-end, from picking areas in the catalog through 9 guided steps of configuration and training, all the way to a fully personalized XAI explanation adapted to my cognitive level. Same technical output, 97% random forest, but they're completely different experience depending on who is looking at it. One pipeline, level appropriated explanation, no loss of scientific rigor. Alright, so here is the setup. 2 IBIS-X sessions running side by side. Same model, same random forest and iris, and same accuracy. On the left, I'm logging as an expert, and the level is 5. On the right, a novice level. beginner, novice, level 1. Now I'm going to ask the exact same question to the XAI chatbot on both sides with the same question, the same model, and we will see how the system adapts. We are just waiting for, yes, as we see, the explanation is already different between an expert and a beginner, the size too. And let's go to the chatbot, and let me start on the expert side. I type my question. Why does the model perform so well? Yep, I copy and the same things to the beginner side, and I just kept, and I will write back. And we are back. Both and show are in, and the contrast is immediate. Look at this same question. Same model, same row, shape, values under the hood, two completely different registers. So we will start by the novice side. The chatbot opens with a metaphor. The flowers have very clear fingerprints. And many small user expert votes on the answer. Then, Then it unpacks the logic in plain English. Petals are the strongest clue. Petal length and width are almost enough to tell the three species apart. Many voters, fewer mistakes. A random forest is a team of decision tree. Each gives its option. The majority win. Setosa is very easy. The model must never confuse it. The few remaining errors between the two look-alike species, versicolor and virginica, and the closing line is deliberately a worm overall. The model is right about 9 times out of 10. Zero jargon. There are cognitive overload. Perfect. Now the expert side, completely different register. The short answer open with a bias variance, trade-off with begging of weakly correlated tree on nearly linear separate classes. Nowhere map, straight to the point. Then it unpacks the feature signals, shape, rank, petal length as 0.454, petal width at 0.412, sepal length at 0.116, 86.66% of the predictive signal sits in petal geometry. Then ensembling bootstrap, sampling, and random subspace selection decorate the trees. Majority aggregations cuts variance while preserving low bias. Then classic geometry, Setosa is linearly separable residual concentrated on the versicolor virginica boundary. Mothering performance F1, macro at 89.97, OOB around 95. And the kickers, the chatbots propose actional levers, class-weighted loss on the versicolor virginica boundary, and then generate feature like petal area or length to width ratio. So look at what just happened. Same question, same model, same accuracy under the hood. the hood, but one answer speaks to a life science teacher who has never touched a confusion matrix, and the other speak to a data analytics who could push this model into production tomorrow. No content dumbing down on the novice side, no useless simplification on the expert side. Each user gets the register that actually helps them learn and decide. And that's the promise of cognitive adaptation in IBIS-X. One chatbot, one model, one question, but a level appropriate explanation every single time. Database gets clearly through analogy, and the expert gets formalization, shaped ranking, and actionable levels. Two different learning paths from the exact same technical core, within sacrificing an inch of scientific rigor.